Good morning, students. Today we are going to discuss about macroprocessor design options. Under that, recursive macro expansion. See, according to that previous classes, we discussed about that particular figure that is uh, like example of the definition of macros within a macro body. With that figure, we presented an example of the definition of one macro instruction by another, how the instruction are changing from one macro instruction to another. See, with that expansion, we discussed how the things are working. With that concept, today we are going to discuss about recursive macro expansion. Figure 4.11a shows an example. Deal with the invocation of one macro by another. Here you need to understand, like, invocation is nothing but how we are going to call one macro to another macros using whatever the information, whatever the instruction we use in that given content. Invocation is nothing but calling the things, calling of one macro by another information, like another macro. Here the purpose of read character according to that 4.11b is to read one character from specified device into register here. We'll discuss about how these things are working here. Device into register A, taking care of the necessary test and wait loop. Here, according to this particular figure, this shows whatever the label field we are observing here. Label field contains read character, then macro ampersand in. This read character will going to read a single character from specified device into register A. See, it will going to read a single character from specified device, whatever the information we received from a device, that will going to read, and then it will going to store it in register A, character into register A. This is with this particular you might observe here, read character macro ampersand in. In can act as a parameter for that particular macro, whatever the definition we used here. Then td test device equals to x ampersand in div, like input device. In is nothing but input device here. With that we are reading whatever the information we pass to that particular system. Single character we are reading, and then we are like storing under that particular register here, register A. See, once we did that, like we need to end that particular information with m and thing. See, this particular whatever the figure, like 4.11 be observed here. This is 4.11a, and then that is whatever the information we observed, that is 4.11 b. Then here, according to this 4.11a, whatever the figure we are observing, this is a main, like initial program. This is read buff can act as a main thing here, like the thing will start with this particular read buff. Read buff is present under that under that label field here. You might observing here one red line here, that is the thing is comes from like this. Whenever your control reaches to this particular read character, then it will concentrate that particular program, because the read character is used to reading a character into register A. Single character we are reading. How to read means whatever the information we observe, like we need to declare read character macro ampersand in, and then we need to test the device. We need to jump subroutine. Then once we jump again, we need to read that initial character, whatever the character comes from that particular device. This is about this particular program. Then recursive macro expansion. According to this figure 4.11c, whatever the thing we are observing here, applied to the macro invocation statement read buff buffer length comma f1. Here read buff can act as the main thing here, buffer length, and then f1 can act as a parameter for that particular read buff here. See, previous classes we discussed about those parameters contain their own set of values here. The procedure expand would be called when the macro was recognized. See here, whenever we expanded, we need to call like macro whenever the thing will be recognizing, the thing will be identifying over there whenever we called a particular macro instructions. See, according to that read buff, that contains buffer length and then f1. These parameter, with that parameter, those parameter contain their own set of values, argument values. The arguments from the macro invocation would be entered into argument table as follows. Initially, before going to enter, we need to assign a certain kinds of values for that particular parameter. We assign a parameter 1 for buffer, parameter 2 for length, parameter 3 for f1, then parameter 4 unused. The boolean variable expanding would be set to true, and expansion of the macro invocation statement would be begin. According to that macroprocessor algorithm, whenever we reach expanding thing, then it will going to set whether it is true or whether it is false. Whenever the thing is set to true, an expansion of the macro invocation would be begin. Whenever the thing is false, the control will be jump to another statement here. The processing would proceed normally until line 50, which contains a statement invoking read character. At that point, process line would call expand again. This time argument table would look like just we are considering f1 for 1, then unused for 2. At the end of this expansion, however, a problem would appear. When the end of the definition read character was recognized, expanding would be set to false. Whenever you have identified a read character, then obviously at the time of end, the expanding would be set to false. Thus the macroprocessor would forget that it had been in middle of expanding a macro when it is encounter the read character statement. It will go into expanding that particular read character whenever we we missed that particular information while calling certain kinds of instructions in that particular programming at the time of expanding. Use a stack to save argument table. Use a counter to identify the expansion. Stack, as you know that things works with LIFO format. Those information will be storing under that argument table. Then we need to use counter to identify the expansion of your instruction. This is about recursive macro expansion. Thank you.